Good day, I'm Mark Selvin Garcia, student from Tarlac State University, and today I'm going to discuss and solve some previous board exam problems about machine elements. By the way, I just chose 7 elements to give an example, so let's start with shaft. And the first example is, so for this problem, we are going to compute the torque by using the pure torsional shear stress formula for hollow shaft, which is S sub S is equals to 16 TD all over pi times the difference of the diameters to the fourth power, where S sub S is the torsional stress, T is the torque, D is the outside diameter, and small letter d is for the inside diameter. Para makompute natin ang torque, we simplify the equation to T is equals to pi times S sub S times d raised to 4 minus d raised to 4 all over 16d. Then substitute natin ang given, and that is T is equals to pi times 120 million Newton per square meter times 0.6 meter raised to 4 minus 0.035 meter raised to 4 over 16 times 0.06 meter, and that is equals to 4,500 Newton meter. Then next problem. So for this problem naman, we are going to use the formula for pure torsional stress for solid shaft, which is S sub S is equals to 16T all over pi d cubed, to get the value of torque which is needed to solve the power transmitted. To solve for torque, we simplify the equation to T is equals to pi times S sub S times d cubed all over 16 and substitute the given value, that is T is equals to pi times 12,000 pound per square inch times 2 inches cube all over 16. Then we get T is equals to 18,850 pound inch. And by using the power formula, P is equals to Tn all over 63,000. Substitute the value of T, that is P is equals to 18,850 pound inch times 120 RPM all over 63,000, and we get P is equals to 35.9 horsepower. Next problem is, so this problem is almost the same from the previous problem. We are going to use again the formula for pure torsional stress for solid shaft. S sub S is equals to 16T all over pi d cubed. And to solve for torque, we simplify the equation to T is equals to pi times S sub S times d cubed all over 16. And substitute natin yung mga given na value, that is T is equals to pi times 59 Newton per square millimeter times 55 millimeter cube all over 16. Then we get T is equals to 1.92739 kilonewton meter. And to solve for power, we use the power formula. P is equals to 2 pi Tn all over 60. Then substitute the value of T and N, so we can get P is equals to 96.88 kilowatt. Next problem is, in this problem, the required is the diameter of the solid shaft. Since there is a given horsepower and angular speed, we can solve for the torque by using the horsepower formula P is equals to Tn over 63,000. And simplifying the formula and substitute the given value, we get T is equals to 75 horsepower times 63,000 all over 1,800 RPM. That is T is equals to 2,625 inch-pound. And to solve for the diameter, we derive the formula for pure torsional shearing stress, and we get D is equals to the cube root of 16T over pi times S sub S, and substituting the torque and the given shearing stress, we get D is equals to 1.306 inches. And for this problem, we are going to derive the formula for pure torsional shear stress. S sub S is equals to TR over J, then J is equals to TR over S sub S, where J is also equals to pi times d raised to 4 minus d raised to 4 all over 32. And to solve for T, we are going to use the power formula P is equals to Tn over 63,000. Then T is equals to P over N multiplied by 63,000. Then substitute the value of P and N. T is equals to 15,000 horsepower over 300 RPM multiplied by 63,000. And we get T is equals to 3,150,000 inch-pound. And to solve for inside diameter, substitute the value of T and the other given value, that is pi over 32 multiplied by 14 raised to 4 minus d raised to 4 is equals to 3,150,000 multiplied by 7 over 7,500. So we can get d is equals to 9.59 inches. For the next problem, to get the maximum torque required in this problem, we need to solve first for the polar moment of inertia for hollow and solid shaft. For hollow shaft, J sub h is equals to pi over 32 multiplied by 0.1 raised to 4 minus 0.07 raised to 4. That is equals to 7.46 times 10 raised to negative 6. And for solid shaft, J sub s is equals to pi over 32 multiplied by 0.07 raised to 4. And that is equals to 2.36 times 10 raised to negative 6. Then solving for torque in hollow shaft, T sub h is equals to S sub s multiplied by J sub h all over r. That is equals to 70 times 10 raised to 6 multiplied by 7.46 times 10 raised to negative 6 all over 0.05. That is equals to 10.44 kilonewton meter. And for solid shaft, T sub s is equals to S sub s multiplied by J sub s over r. That's equals to 70 times 10 raised to 6 multiplied by 2.36 times 10 raised to negative 6 all over 0.035. That is equals to 4.714 kilonewton meter. Then solving for the torque in consideration of the twist angle, using the formula theta is equals to summation of TL over JG, that is 2.5 times pi over 180 is equals to T times 2 over 7.46 times 10 raised to negative 6 multiplied by 83 times 10 raised to 9 plus T times 1.5 over 2.36 times 10 raised to negative 6 multiplied by 83 times 10 raised to 9. That's T is equals to 4.0 kilonewton meter. Next problem. In this problem, we are required to calculate the extreme fiber stress in drive shaft, neglecting the other losses, so we can use again the formula for pure torsional shear stress for solid shaft. S sub s is equals to 16t over pi d cubed, where t is equals to 3000 times 14 over 2 multiplied by 11 over 40, and that is equals to 5775 inch-pound. Then substitute the value of t and the given diameter in the stress formula. S sub s is equals to 16 times 5775 all over pi times 1 raised to 3. That is S sub s equals to 29,400 psi. So next element is the bolt and screws. So the first problem. So for this problem, we can solve the weight by using the formula efficiency is equal to power output over power input equals to WL over 2 pi RF. And by substituting the given values, 0.8 is equals to W multiplied by 0.5 all over 2 pi multiplied by 50 times 30, and that is the weight is equals to 15,000 0.79.64 pound force. Next problem. For this problem, to solve for the torque on the set screw, we are going to use the power formula P is equals to Tn over 63,025. And simplifying the equation and substituting the given values, that is T is equals to 3 horsepower over 150 RPM multiplied by 63,025. We can get T is equals to 1,260.5 inch-pound. For this problem, since the power, angular speed, and the diameter of the shaft is given, we can use the formula P is equals to D times N times D raised to 2.3 over 50 horsepower per screw. Simplifying equation to D is equals to 2.3 root of 50 times P over D times N. Then substituting the values, D is equals to 2.3 root of 50 times horsepower is equals to 2 inches times 150 RPM. Then we get D is equals to 0.74 inches. That is the typical size of screw that is required. For the next problem, To solve for the power transmitted over the screw, we use the formula P is equals to D times N times D raised to 3 over 50 horsepower per screw. Then substituting the values, P is equals to 1 inch times 1000 RPM times 3/8 inch raised to 2.3 all over 50. And then we get P is equals to 2.096 horsepower per screw. So in this problem, we need to use the formula F is equals to T over R, where T is equals to P over N times 63,025, that is equals to 3 horsepower over 150 RPM times 63,025 is equals to 105 foot-pound. Then we can solve for the force. F is equals to 105 foot-pound over 1 inch multiplied by 1 foot per 12 inch, and we can get 1,206 pound. And for the holding force, multiply the force by the factor safety, that is equals to 3,780 pound. Next problem. To solve for the external torque to this problem, we are going to use the formula for American Standard Threads, which is T is equals to WD sub M over 2 multiplied by 0.866L plus FD sub M over 8.866 dm minus F times L multiplied by 2. And note that L is equals to 1.0 times 1.5, that is 1.5. And substitute the given values to the formula. T is equals to 2,500 multiplied by 9.026 over 2 multiplied by 0.866 times 1.5 plus 0.2 times 9.026 all over 0.866 times 9.026 minus 0.2 times 1.5 multiplied by 2. Then we get T is equals to 6.48 Newton meter. So by using the formula S sub T is equals to F over A, where F is equals to pi multiplied by 14 square over 4 multiplied by 125, that is equals to 19,250 pound. And FB is equals to 19,250 pound divided by 14, that is equals to 1,375 pound. Then substitute in the stress formula, 3,000 psi is equals to 1,375 pound per pi d square over 4 for the area. We can get D is equals to 0.76 inches. Then the next example is about the flywheel. So the first example, solving for the weight of the flywheel using the formula of kinetic energy. Delta K is equals to W sub F over 2G multiplied by V sub 2 square minus V sub 1 square. Then simplifying the equation to W sub F is equals to 2G multiplied by delta KE all over V sub 2 square minus V sub 1 square, where V sub 1 is equals to pi dm n1 and V2 is equals to pi dm n2. And substituting the given values, WF is equals to 2 times 9.81 times 2,380 all over pi times 0.9144 times 160 over 60 square minus pi times 0.9144 times 180 over 60 square, and we get W sub F is equals to 2,996 Newton. And by dividing the gravitation constant, we can get W sub F is equals to 305 kilograms. So in this problem, to determine the capacity of the flywheel, we need to solve for the linear velocities by using the formula V is equals to pi dn. For V sub 1 is equals to pi times 48 times 120 all over 12 times 60 is equals to 25.13 fps. And solving for V sub 2, V sub 2 is equals to pi times 48 times 100 all over 12 times 60 is equals to 20.94 fps. Then substitute the value to the formula delta K is equals to 1.12 W multiplied by V sub 1 square minus V sub 2 square all over 2G. Then we get delta K is equals to 1.12 times 800 times 25.13 square minus 20.94 square all over 2 times 32.2. And the answer is 2,685.68 foot-pounds. The next problem is, so to solve for the weight, we are going to use the formula delta E is equals to W sub F times C sub F times V square over G. Then simplify the equation to W sub F is equals to delta E times G all over C sub F times V square. Then substitute the given values in the equation, that is W sub F is equals to 2000 times 32.2 over 0.2 times 66 square. So we can get an answer of 73.92 pounds. By using the formula for the coefficient of fluctuation, CF is equals to V sub 1 minus V sub 2 over V average is also equals to N sub 1 minus N sub 2 all over N average. We can directly solve for C sub F, where C sub F is equals to 300 minus 280 over 300 plus 280 divided by 2. So we can get CF is equals to 0.069. So in this problem, by using the equation T is equals to L times alpha, where L is equals to 1 half M multiplied by R squared, that is equals to 1 half times 800 times 1.5 over 2 square, and that is equals to 225 kilogram meter square. And alpha is equals to 100 multiplied by 2 pi over 60, and it is equals to 10.472 radians per second square. And from the equation, T is equals to 225 times 10.472, we can get torque is equals to 2,356.19 Newton meter. In this problem, to compute for the kinetic energy lost by flywheel, we need to solve for the minimum and maximum velocities. And V sub 1 is equals to 2 pi times 0.375 times 3. That is equals to 7.069 meter per second. And V2 is equals to 2 pi times 0.375 times 2.8. That is equals to 6.597 meter per second. And after we solve for the velocities, we can also for the energy loss. We use the formula delta KE is equals to 1 half multiplied by M times V sub 1 square minus V sub 2 square. And simplify the solved velocities, that is delta KE is equals to 457 multiplied by 7.069 square minus 6.597 square over 2, and we can get an answer of 1,473.91 Newton meter. Next problem. Solving for the mass moment of inertia, I sub m is equals to mk square, that is equals to 175 multiplied by 0.380 square, that is equals to 25.27 kilogram meter square. And solving for the angular acceleration, alpha is equals to w sub f minus w sub 0 and all over t, and that's equals to 2 pi times 500 over 60 minus 0 all over 30, and that is equals to 1.745 radians per second square. And to solve for the torque, T is equals to I sub m multiplied by alpha, and we can get 25.27 times 1.75, that's equals to 44.1 Newton meter. Next problem is all about springs. The first problem is, so to solve for the wall factor, we need to solve first for the spring index, which is C6 is equals to D sub m over D equals to 1 over 1/8, and that is C is equals to 8. And from the formula, K sub W is equals to 4C minus 1 over 4C minus 4 plus 0.615 over C. Substitute the value of C, and that is K sub W is equals to 4 times 8 minus 1 over 4 times 8 minus 4 plus 0.615 over 8. Then we get K sub W is equals to 1.184, which is the wall factor of the spring. The next problem is, for the correction factor of the spring, we are going to use the formula K sub C is equals to K sub W over K sub S, where K sub W is equals to 4C minus 1 over 4C minus 4 plus 0.615 over C, where C is equals to D over D is equals to 1 over 1/8 is equals to 8. We get 1.184 for the wall factor, and for the K sub S is equals to 2C plus 1 over 2C, that is equals to 1.0625. And for the curve correction factor, Kc is equals to 1.184 over 1.0625, that is equals to 1.1144. Next problem. From the Weierstrass factor, K sub B is equals to 4C plus 2 over 4C minus 3 is equals to 4 times 8 plus 2 over 4 times 8 minus 3, that is equals to 1.172. By using the formula of the maximum shearing stress is equals to 8 times K sub B times F times C over pi d square, we can solve for the wire diameter, where d square is equals to 8 times K sub B times F times C over pi times S sub S max, that is equals to 8 times 1.172 times 130 times 8 over pi times 50,000, that is equals to 0.0621 square inch, and the square root of the answer is D is equals to 0.25 inch. To compute for the mean diameter of spring using spring index, C is equals to D over D, where D is equals to D times C, that's 0.25 inch times 8, and the answer is D is equals to 2. And in next problem, this problem, since the springs are hooked in series, using the formula 1 over K sub E is equals to 1 over K sub 1 plus 1 over K sub 2 plus 1 over K sub 3, and by using the given values, we can solve for K sub E, and it's 1 over K sub E is equals to 1 over 4 plus 1 over 6 plus 1 over 6, that is 1 over K sub E is equals to 7 over 2, and then that is K sub E is equals to 12 over 7 equals to 1.71 kilonewton per meter. Next problem. To solve for the total deflection, use the formula delta T is equals to delta 1 plus delta 2, where delta 1 is equals to F over K sub 1 and delta 2 is equals to F over K sub 2. And by deriving the formula, we get delta T is equals to F multiplied by K sub 1 plus K sub 2 all over K sub 1 times K sub 2. Then substitute the values. Delta T is equals to 100 times 9.8066 times 4 plus 6 over 4 times 6, and the answer is delta T is equals to 408.6 millimeter. By using the formula E is equals to 1/2 times F times delta, where J is equals to pi d raised to 4 over 32, then substitute the value of J to the formula S sub S is equals to TR over J, so we can solve for F. 250 is equals to F times 20 times 2.5 all over pi times 5 raised to 4 over 32, that is F is equals to 306.8 Newton. Then from the formula, E is equals to 306.8 over 2 multiplied by 0.02, that is equals to 3.068 joules. Next problem is, in this problem, we can solve for the velocity simply by using the formula V is equals to square root of 2g times the sum of h and y, and from the formula G is equals to 9.81, and H is equals to 1.5, Y is equals to 0.203, we can get an answer of 5.78 meter per second. So for this problem, from the power formula, P is equals to F sub 1 minus F sub 2 multiplied by V all over 33,000, where V is equals to pi dn. Then P is equals to 300 minus 50 multiplied by pi of times 84 over 12 times 150 all over 33,000. Then we get an answer of P is equals to 25 horsepower. To solve for the width of the belt, we use the formula 550 horsepower over V is equals to B times T times S sub D minus 12 times rho times V square over G multiply by E raised to F times theta minus 1 over E raised to F times theta, where V sub S is equals to pi dn over 60, and it is equals to pi times 24 over 12 times 370 all over 60. That is V sub S is equals to 38.75 feet per second. Then from the formula, 550 multiplied by 30 over 38.75 is equals to B times 38 multiplied by 400 minus 12 times 0.035 divided by 32.2 times 38.75 raised to 2 multiplied by E raised to 0.45 pi minus 1 divided by E raised to 0.45 pi, and the width of the belt required is B is equals to 3.94 inch. This problem, solving for the angular speed of the driver, 1280 is equals to pi times 1.219 times the angular speed times 1 minus 0.015, and that is n is equals to 452.6 rpm. Then solve for the speed of the driver. From the formula, V is equals to pi dn over 60. Substitute the given values as V is equals to pi multiplied by 0.914 times 452.6 all over 60. Then V is equals to 21.66 meter per second. So in this problem, using ratio and proportion, we can solve for the diameter of the larger sheave using the formula N1D1 is equals to N2D2, and that is 1150 times 8 is equals to 400 times D2, and we can get D2 is equals to 23 inches. And assume C is equals to D2, and it is also equals to 23 inch. Then to compute for the length of the belt, substitute the given values to the equation. L is equals to pi over 2 multiplied by D1 plus D2 plus 2C plus D2 minus D1 raised to 2 over 4C. That is L is equals to pi over 2 multiplied by 8 plus 23 plus 2 multiplied by 23 plus 23 minus 8 raised to 2 over 4 times 23. Therefore, the length is equals to 97 inches. So in this problem, we can solve the belt net tension by using the formula F net is equals to F1 minus F2. It is also equals to 2T over D, and equals to 2 over D multiplied by 63,000 HP over N. And substituting the given equation, this equals to 2 over 6 multiplied by 63,000 times 20 over 2,000. We can get 210 pounds. So for the length of an open belt, L1, we use the formula L1 is equals to pi over 2 times D1 plus D2 plus 2C plus D2 minus D1 square over 4C. Then L1 is equals to pi over 2 times 1,200 plus 910 plus 2 times 3,600 plus 1,200 minus 910 raised to 2 over 4 times 3,600. That, and L1 is equals to 10,520.22 millimeter. Then for the length of for cross belt L2 is equals to pi over 2 times D1 plus D2 plus 2C plus D2 plus D1 square over 4C, and L2 is equals to pi over 2 times 1,200 plus 910 plus 2 times 3,600 plus the summation of 1,200 and 910 raised to 2 over 4 times 3,600, that is equals to 10,823.55 millimeter. Then solving for the difference in length, delta L is equals to L2 minus L1, that is 10,823.55 minus 10,520.22, that's equal to 303.33 millimeters. The next problem. In this problem, to solve for the angular speed of the driver, we simply substitute directly the given values to the formula. V is equals to pi dn multiplied by 1 minus the percent slip, and we get n is equals to V over pi d multiplied by 1 minus the percent slip. Then n is equals to 1,280 over pi times 0.914 times 1 minus 0.015. Then we get n is equals to 334.74 RPM. Then the next machine element is the brakes and clutches. Formula P is equals to 2 pi Tn over 60. We can solve for the torque. T is equals to 7 times 10 raised to 3 times 60 all over 2 pi times 500. Then torque is equals to 133.69 Newton meter. Then using uniform wear method, T is equals to F times F over sine theta multiplied by R plus R over 2, but Rm is equals to R plus R over 2, that is also equals to dm over 2. Then we get 0.15 meter. And solve for the axial force, 133.69 is equals to 0.42 F over sine 10 degrees multiplied by 0.15, and then we get the axial force is equals to 368.5 Newton. So this problem is almost the same from the previous problem. We can solve for the torque using uniform wear method. T is equals to F times F over sine theta multiplied by R plus R over 2, where Rm is equals to dm over 2 and is equals to 0.2 divided by 2 is equals to 0.1 meter. Thus T is equals to 0.45 multiplied by 550 divided by sine 10 degrees multiplied by 0.1. So we get an answer of T is equals to 142.53 Newton meter. So on this problem, solving for the axial force Fn from the equation T is equals to 2Fn multiplied by F divided by 3, and then multiply by R raised to 3 minus R raised to 3 over R raised to 2 minus R raised to 2, where R sub 1 is equals to 350 minus 2 multiplied by 75 sine 20 all over 2, that is equals to 149.35 millimeter. Then R is equals to R plus R sub 1 over 2. It is equals to 175 plus 149.35 divided by 2. Then it is equals to 162.17 millimeter. Thus 215,000 is equals to 2 Fn multiplied by 0.2 divided by 3, and then it is multiplied by 175 raised to 3 minus 162.17 raised to 3, and it is divided by 175 raised to 2 minus 162.17 raised to 2, So we can get Fn is equals to 6,363.4 Newton. For this problem, using the equation T is equals to 2 pi F multiplied by P sub n multiplied by R sub m raised to 2 multiplied by W, where T is equals to 63,000 multiplied by 40 over 1,250. It is equals to 2,015 inch-pound. And then R sub m is equals to R plus R divided by 2. That's equals to R plus R minus W sine 12.5 all over 2. It is equals to R minus 0.1082 W. And then we can solve for the width. 2015 is equals to 2 pi multiplied by 0.2 multiplied by times 12 times 7 minus 0.1082 W square multiplied by W, then W is equals to 3 inches. So for this problem, to solve for the axial force, we use the formula T is equals to 60 times P over 2 pi, and it is also equals to F multiplied by F sub A times R sub F times N, where F is equals to 0.4, R sub F is equals to dm over 2, and it is equals to 0.19 divided by 2 equals to 0.095, and N is equals to 2. Then substitute in the equation 60 times 33.5 times 0.46 all over 2 pi is equals to 0.4 times F sub A times 0.095 times 2. We get F sub A is equals to 3.14 kilonewton. From the equation S sub T is equals to F1 over B times T, we can solve for width. B is equals to F sub 1 over S sub T times T, then substitute the given. B is equals to 9.656 times 10 raised to 3 over 55 times 4. Therefore, B is equals to 43.89 millimeter. To solve for the power, we need to calculate the torque using the uniform wear method. T is equals to F times R sub F times N. It is equals to 0.3 times 100 times 2 times 6 equals to 360 inch-pounds. Then for the power, P is equals to 2 pi Tn over 33,000. Substitute the values of T and N. P is equals to 2 pi times 360 over 12 times 400 all over 33,000. We get P is equals to 2.28 horsepower. And to solve for the tangential force, we need to use the formula T sub A is equals to F sub T times R sub A. That is equals to 236,000 is equals to F sub T times 207. We get F sub T is equals to 1140.1 Newton. And for the resultant force, cosine theta is equals to F sub T over F sub R, where theta is equals to 14.5 degrees. Then we get F sub R is equals to 1140.1 over cosine 14.5 degrees, and that is equals to 1177.6 Newton. In this problem, using the equation P is equals to F sub 1 times V, where V is equals to pi dn over 60, we get F1 is equals to 60 times P over pi dn. Then substitute the given values. F1 is equals to 60 times 25,000 all over pi times 0.1 times 600. We get an answer of 7,957.75 Newton. Next problem. So based on the speed ratio, the speed of the driver over the speed of the driven is equals to n sub 1 over n sub 2 is also equals to d sub 2 over d sub 1 and equals to t sub 2 over t sub 1. That's equals to 7 over 9. And solving for the number of teeth of gear, C is equals to T sub 1 over 2 P times D multiplied by 1 plus N1 over N2. And 16 is equals to T sub 1 over 2 times 8 multiplied by 1 plus 7 over 9. That is T1 is equals to 144 teeth. And solving for the number of teeth of the pinion, T2 is equals to T sub 1 times T sub 1 is equals to N2. That's equals to 144 times 7 over 9. That's equals to 112 teeth. In this problem, we are going to solve for the bore diameter of each gear. And to solve for that, we need to calculate the torque. To solve for the torque, we use formula P is equals to Tn over 63,025. It is 500 is equals to T times 3,600 over 63,025. And we get the torque is equals to 8,753.47 inch-pound. And then solving for the shaft diameter, S sub S is equals to S sub SD, where S sub S is equals to 16T over pi d cube. That is equals to 16 times 8,753.47 all over pi d cube is equals to 12,500. And we get an answer of D is equals to 1.5278 inch. From PSME code, N is equals to 80 times P over D cube. Then substitute the value of P and D. Then N is equals to 80 times 250 over 52.5 over 25.3 cube. And N is equals to 2,264.92 RPM. From the equation, P is equals to 6.2832 C over N, where C is the center distance, N is the total number of teeth in both gears. P is equals to 6.2832 times 10.2230 over 60 plus 20. And we got an answer of P is equals to 0.8035 inch. For this problem, we are going to use the equation T is equals to 1.571 over P, where T is the circular thickness and P is the diametral pitch. T is equals to 1.571 over 5. We got an answer of T is equals to 0.3142 inch. And that is the end of discussion. All the problems discussed are from the book of Solved Problems in Machine Design by Engineer Capote and Engineer Mandaue. Thank you for listening.